Hi everyone, and welcome to section 9.2, which deals with simplifying square roots. Are you excited? This is our last chapter, so we just have a few more sections to go through, and then that's it. Then you get ready for your final. Are you excited? I'm excited for you. Okay, so we're going to talk about product and quotient property. Okay, so first of all, what's a simplified square root? Like, how do we know that it's even simplified? Basically, a simplified square root is when there's no perfect square factors underneath the radical. Okay, so let's say, for example, you have here, square root of, 50. Well, square root of 50 is the product of 25 times 2, right? I mean, 50 is the product of 25 and 2. And 25 is a perfect square root. So square root of 50 is not simplified. We have to simplify it. So when we do this, we separate it this way, then you can see we can use what's called a product property. Okay, so we can rewrite that as square root of 25 times square root of 2. And then square root of 25 is just 5. So square root of 50 is 5 root 2. Now this is simplified because, you cannot, there's no perfect square roots underneath the radical here. So that's it. Okay, so let's do a couple more examples. Oh, I just did that one. Haha. We know that this one is square root of 25 times 2. This is supposed to be a 5, which is square root of 5 times square root of 2, 25, which is just 5 root 2. Okay. How about 500? Well, that's square root of 100 times 5, which is the same as square root of 100 times square root of 5. So eventually you would be able to skip this step and then just go to, whoa, sorry, I don't know what just happened. How do I undo that? Okay, which is 10 square root of 5, okay? All right, how about if you have something like x cubed? Now remember, the square root function eliminates things in pairs, so it's a lot easier. So if you can rewrite this as the product of the nearest even number and, what's left over. So square root of x cubed is the same as saying square root of x squared times x. And so square root of x squared, well, that's just going to be x square root of x, and that's it. Okay, and then here you have square root of 25 times y cubed. Well, 25 is already a perfect square, so that's nice. But y to the power 5, we can rewrite this, not cubed, y to the 4th power times y. And then square root of 25 times square root of y to the 4th times square root of y. This is just going to be 5y squared. Remember that it takes the exponent and divides by half, square root of y, okay? So let's do a couple more. Here we have a square root of 72n squared. N to the power 7. I don't know why I keep saying the wrong thing. Okay, so again, we separated we can think about this as square. What are the perfect squares? 9, right? 9 is in here, so 9, 8. What else? 36 times 2 is 72, so 36 times 2. And then n to the power 6 times n will give you 7. So you can commute this. You can write this as 36 n to the power 6 times square root of 2n. Well, this is just going to be 6n to the power 3 square root of 2n. And why? Because square root of 36 is 6. Square root of n to the power 6 is n cubed. So that's that. Okay, so how about this one? 63 is 9 times 7. And we can write this apart here. 9 times 7 times u squared times u times v to the 4th power times v. So all the even number exponents we can put together, and then the perfect squares. You can use commutative property. Eventually, you could use commutative property in your mind. You don't have to rewrite all of this, but just for now, okay, I put these 3 together here at first, and then the rest is going to be 7 times u times v. So that's just these 3 here. These 3 that are left, right? That's this part right here. And so finally, square root of 9 is 3. Square root of u squared is u. Square root of v to the power 4 is v squared. Then what's left inside the radical is a 7u to the 7uv. That's it. And that's it. That's simplified because you can't simplify this further, okay? All right, let's do some more here. How about 3 plus a square root of 32? Well, what is the square root of 32? What's the perfect square, the highest perfect square that divides into it? If you said 16, you're correct. So this is 3 plus square root of 16 times 2, which is 3 plus 4 root 2. We can't combine these, so that's it. That's your answer. How about over here? We have 4 plus square root of 48 times 2. Well, we know that 48 is 16 times 3. So that's going to be 4 minus square root of 16 times 3 all over 2. Well, square root of 16 is 4. So this is 4 minus 4 root 3 divided by 2. But then you could think of that as 4 over 2 minus 4 root 3 over 2, property of fractions. And that simplifies to become 2 minus 2 root 3. And that's it. Okay. The last thing we want to go over is quotient property, which is basically you can rewrite the square root of a quotient as a quotient of 2 square roots. So basically, you would do that and then simplify the numerator and the denominator separately. Okay, so let's say here you have 27m cubed divided by 196, 196, right? And that's the square root of the entire thing. Now, 196, I believe that's a perfect square, right? It's 14 squared. So here you have, let's look at it this way. So 27 m cubed, square root of m cubed over square root of 196. The square root of 196 is just 14, so that's nice. So you have 14 on the bottom, right? And the square root of 27m cubed, well, that's just 9 times 3 times m squared times m, right? So that becomes, so these come out, right? They become 3m on the outside, and what's left is 3m on the inside, and then that's all over 14, and we cannot do anything else other than that. So we leave it as is. So how about here? We have 48x to the power 5 over 100, the square root of all of that. So square root of 48, that's going to be, can I simplify this? That's 16 times 3. And then x to the power 5th can be written as x to the power 4 times x. And that's all over square root of 100. Well, we know that's 10. So you just let that be 10. But on the top, here's our perfect squares. That's going to be 4x squared on the outside of the radical. And then what's left is a 3x. Okay, so then can we reduce this? These are both even. So dividing top and bottom by 2, your final answer, 2x squared, square root of 3x all over 5. And that's it. Let's do a couple more. What if you were here? Let's see, square root of 21 over 64. Well, that's square root of 21 over square root of 64, I mean. So that's going to be on the top. It's going to be 8. I mean, on the denominator is going to be 8. Square root of 21. Well, 21 is just 3 times 7. There's no perfect square, so we leave it as is. How about this here? Square root of 45 x to the power 5 over square root of y to the power 4. On the denominator, you get y squared. And then on the top, you have 9 times 5, x to the 4 times x. So that's just 3x squared. And then what's left over is a 5x on the inside the radicand, and then you have the radical, and then that's it. There you go. Okay, let's do one more with some more letters. Yay, we love this. Okay, so on the top, you have here square root of 1 d to the power 9. Square root of 81. So that's 81 d to the 8th power times d. All over square root of 25 d to the power 4. Well, these are perfect squares here. So you have 9d to the 4th because it's half of 8. And then what's left is square root of d. And then on the bottom is just 5d squared. Now these can reduce. D squared goes into d to the 4th 2 times. Remember, top minus bottom. So we have 9d squared square root of d. Uh-oh, why did I write it to? D all over 5. And that's it. Okay. Now on the top, last one here, we have... here on the top, we have square root of 9 times 2, p to the power 4 times p, q to the power 6 times q. How do I know again? I just take the largest, I separate the the variables with the highest even number times 1 of it. So then we have here on the bottom, square root of 32 is 16 times 2, okay, times q squared times p, because these are the perfect squares. I mean, I kind of here. And then let's circle our perfect squares here, here, here. So on the top, we have 3p squared q to the power 3. And then inside, we have 2pq. So 2pq. And then the bottom, you have 4q. And on the inside, you're going to have left is a 2p, right? So, so this will cancel out with this here, too. So you have here 3p squared q to the power 2 times 2p times square root of q all over 4, and then square root of 2p, and then that can cancel out, and then you just have square root of q. So final answer, oh my goodness, where can I write my final answer? I'll write it in pink so it's obvious. 3p squared q squared square root of q all over 4. Okay, and on that note, that goes over here. Here's your super fun homework. Good luck, happy studying, and I will see you on the next video.